Okay, so today we're going to graph functions on an interval. An interval is something that looks like this, and we're going to talk about it in a moment. So we're going to go ahead and graph the function f of x equals negative 2x plus 1, except only on the interval negative 3 is less than or equal to x is less than or equal to 2. Essentially what this is saying is we're going to graph this function on all the x values between and including negative 3 and 2. So we're not going to graph it anywhere further than that. So to quickly show you what that looks like, again, it says x. So this is my x-axis. So I'm going to graph this function between negative 3, which is here, and 2. So I'm not going to graph the function anywhere over here or anywhere over here. Just between these two spots. So to start, I'm going to start at my lowest x value, which is negative 3. I'll go to negative 2, negative 1, 0, 1, and 2. I won't grab any more points besides those ones. So I'm only going to evaluate this function at these 5 points. So we'll get started. So f of negative 3 would be negative 2 times negative 3 plus 1. Negative times negative is a positive. 2 times 3 is 6. And 6 plus 1 is 7. I'm going to do f of negative 2, which is negative 2 times negative 2 plus 1, which is a positive 4, and then that's 5. I'm going to do negative 1, which is negative 2 times negative 1 plus 1. This is a positive 2. Positive 2 plus 1 is 3. Now I'm going to pause there. I notice that this is a linear function because it's just an x. I notice that what I'm doing is I'm adding 1 to the x values, and I'm subtracting 2 from the y values. So I'm going to use that pattern to continue. So 3 minus 2 is 1. 1 minus 2 is negative 1. And negative 1 minus 2 is negative 3. So again, I'm going to graph this function, but only between these two values. So plot these points, negative 3, 7. So 1, 2, 3, 4, 5, 6, 7 goes here. Negative 2, 5. 1, 2, 3, 4, 5. So the point goes here. Negative 1, 3. 1, 2, 3. 0, 1. 1, negative 1. And 2, negative 3. And this time I'm going to go ahead and I'm going to draw a line to represent all values in between there. Let's do one more together just to practice. So this time we're going to graph g of x equals x squared minus 3 on the interval negative 5 to 1. So we're going to graph this from negative 5 to 1. Notice that this is a quadratic, so I should expect a parabola or a U-shaped. So the x values I need are negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. So let's get started. F of negative 5 would be negative 5 squared minus 3. Negative 5 squared would be a negative 5 times negative 5, which is a positive 25. And 25 minus 3 is 22. So that's pretty high up there. Let's do the next one. F of negative 4 is negative 4 squared minus 3. Negative 4 squared would be negative 4 times negative 4, which is positive 16. And 16 minus 3 is going to be 13. Negative 3, so f of negative 3, which will be negative 3 squared minus 3, which will be a positive 9 minus 3, which is 6. Negative 2, so f of negative 2, which is negative 2 squared minus 3, which is 4 minus 3, which is 1. F of negative 1, I'll put it here, equals negative 1 squared minus 3, 1 minus 3, which is negative 2. 0, I have run out of space. Let me go down to this scratch paper here. F of 0 is 0 squared minus 3, 0 minus 3, which is negative 3. Last but not least, f of 1, 1 squared minus 3, 1 minus 3, which is again negative 2. So I'm going to go ahead and graph this. So negative 522 is way off of my graph. I think the first one I can graph is negative 3, 6. I just drew my graph too small. Negative 2, 1. Negative 1, negative 2. 0, negative 3. And then 1, negative 2. So your graph should look like a parabola, or at least part of it, and look something like that.